uh, here. Good afternoon, everybody. I'm Sharon Megdal, Director of the Water Resources Research Center, and it's my pleasure to welcome you to today's WRRC Water Webinar, The Three Ages of Water, Prehistoric Past, Imperiled Present, and Hope for the Future. Peter Gleick, who I'll properly introduce in just a moment, will be speaking about his book. I'd like to ask the attendees to please keep yourself muted. We have a great turnout for today's webinar. The presentation by Dr. Gleick will be followed by Q&A. I invite you to put your questions in the chat. I'll moderate those at the end after his lecture. And there will be a recording of this. It's already going. And the recording will be posted. All of you who have registered will get notification when the recording and the slides are posted. I do want to respectfully acknowledge that the University of Arizona is on the land and territories of indigenous peoples. Today's Arizona is home to 22 federally recognized tribes, with Tucson being home to the O'odham and the Yaqui. The university strives to build sustainable relationships with sovereign Native nations and indigenous communities through educational offerings, partnerships, and community service. I would like to bring your attention to some of our upcoming events. We have a co-sponsored event with the Native Voices in STEM Spring Seminar Series tomorrow at noon. And then on March 19th, we have another co-sponsored event in that series. On March 28th, we have a Friday noon webinar talking about our Transboundary Aquifer Assessment Program. That'll feature Elia Tapia. And then on April 11th, we'll have Scottsdale, Phoenix, and Tucson water directors talking about their plans for advanced water purification in Arizona. And we'll be adding things. The way to keep in touch with what's going on is through subscribing to our weekly wave. You'll see a link and QR code there for that, or check anytime our events page. We also have our big annual event coming up, our annual conference. The focus this year is on shared borders, shared waters, working together in times of scarcity. We just opened up registration late last week. The basic agenda is posted. We'll be updating it as speakers are confirmed. That will be here in Tucson at the University of Arizona Student Union Memorial Center. So please mark your calendars for that. Plan to join us. A non-interactive live stream will be available for that as well. And for any who are maybe students or teachers of students here at the University of Arizona, we did just also advertise the special summer internship that we have available this summer, and we're inviting applications for that. So lots going on. Please visit our website and subscribe to our weekly wave. So with that, it is my distinct pleasure to introduce Peter Gleick, who's a leading scientist, innovator, and communicator on water and climate issues. He's a co-founder of the Pacific Institute in Oakland, California, which was established in 1987, an independent non-governmental research center creating and advancing solutions to the world's most pressing water challenges. He's currently president emeritus and senior fellow at the Institute. Peter is also a MacArthur Fellow, which is very prestigious to have received a MacArthur Award. And he's an elected member of the U.S. National Academy of Sciences and the American Academy of Arts and Sciences. In 2018, he was awarded the Carl Sagan Prize for Science Popularization. His most recent book is The Three Ages of Water that he'll be talking about today. So while we can't promise that Peter can do in-person signing, I know he's going to do a great job telling us about the content of his book. He's going to speak for maybe about 40 minutes or so, after which we'll open it up for some moderated questions. So Peter, the floor is yours, and welcome and thank you. And thank you all for being here with us.
Okay, very good. Thank you, Director Megdal. I greatly appreciate the invitation of the center to have me present today, and thank you to all of you for coming and listening. I'm going to talk about the three ages of water, my idea about the human history of water, the challenges that we face, and as I hope I will get across, the last section of that book is called A Hope for the Future, a vision, a positive vision of where I think we could be on many of the challenges that face us in water. I'm going to share my slides. Let me go ahead and do that. Okay, hopefully you can all see that. We're in a crisis, I would argue, a series of crises, more accurately, threatening the health of the planet and, of course, our own health. It's a crisis in many ways of our own making. It's been developing for centuries, slowly and incrementally in different ways and in different places and in different forms. But it's now reaching a crescendo. It's coming together in more than just small local problems, but now it includes global climate change, ecological collapse, expanding economic and political failures, and widening conflicts and violence. And a core part of these crises are the challenges and threats associated with water, with the planet's hydrologic cycle and the fresh water resources that we all depend upon. The title of my talk and the title of my book is The Three Ages of Water: Prehistoric Past, Imperiled Present, and a Hope for the Future. And as I'll describe, the first age of water is the period of time from the very creation of the universe through the formation of our own solar system and our own planet, the evolution of life, including our own species, and the development of the very earliest societies and empires, and the role that water played in all of these aspects. The second age of water I'll describe is our age, when humans had to develop the technologies and the institutions and the strategies to manage and manipulate the hydrologic cycle for the benefit of growing populations and our economies. And the second age of water, again, our age, is coming to an end now in these crises I've mentioned, the result of a series of unintended consequences for the environment and people and the planet. But my argument and my core message is that we're living in a remarkable time, a time when I think we're in a transition from the challenges that many of us are working on to a positive, sustainable future, the idea of a third age of water. And my focus is water, but I suspect that many of the points that I'll raise will resonate with people here who may be working on other aspects of these challenges, technical, engineering challenges, energy, climate, ecosystems, economic and social and policy pieces of all of these intertwined pieces of the puzzle. And if one of my messages is that we're now in a transition to a positive future, another is that we're not going to solve our problems with the tools and the institutions and the thinking that led us to the problems today, the things that either caused or kept us from solving these problems. We need a new way of thinking and a new way of doing, and that's what I call the third age of water. So what do we really know about water, about what it is and where it comes from and the role that it's played in the history of Earth or indeed in the cosmos or in the evolution and development of humanity? And what can history, science, and experience tell us about the potential to solve our water problems and move to a sustainable future? That's what this story is about. Science tells us that the very first hydrogen atoms were likely formed perhaps minutes, maybe a few thousand years after the Big Bang. And oxygen took a little bit longer. The first stars had to form, they ignited, they exploded, and they created and spread oxygen into the expanding universe. But when we had oxygen and hydrogen, we had water. And science also tells us that water is ubiquitous throughout the universe. Everywhere we look, we see water on other planets, on moons in our own solar system, in asteroids and comets, in interstellar space, throughout the Milky Way, and we see water in other galaxies. Ice has been found in the deep craters on Mercury, protected from the blazing heat of the sun. It's been found in the blistering atmospheres of Venus, in ice, snow, and groundwater on Mars, and craters on our own moon, and venting from the surface of the moons of Saturn and Enceladus here. This is an image of water actually venting from the surface of Enceladus, which is a moon of Saturn. Interestingly enough, just this week, a private company landed a small lander on the moon, and another small lander is on its way to the moon. And the places where they're landing on the moon are places where we think there may be water, which is vital for ultimately the creation of oxygen, for the support of life on any other planet, for the creation of fuel. Water is ultimately critical for our exploration of the solar system. The frozen planets Uranus and Neptune, for example, have more water than is actually here on Earth. And our own water almost certainly came with the primordial dust and gases that formed our own planet more than 4 billion years ago. And science tells us that without water, there wouldn't be life. Well, maybe. We only have one example to draw from, but certainly without water, you and I and life as we know it wouldn't exist. And this is all part of the first age of water, the billions of years from the Big Bang to the formation of our planet, to the ultimate evolution of Homo sapiens and the earliest cultures and empires. As early species of hominins, the family that includes our own, Homo sapiens, evolved in Africa millions of years ago, the presence and absence of water and the variations in climatic conditions over time were key to the success or failure of our ancestors. And in these early years, as human populations expanded beyond the first thousands to the first millions, and then spread over the continents to Egypt and Mesopotamia and the floodplains of the Indus Valley in Asia, and along the great rivers in China and along to Australia, and ultimately to the vast rainforests and grasslands and savannas of the Americas, these early populations were fundamentally dependent on their ability to successfully deal with the hydrologic cycle, to deal with droughts and floods. And these early populations created writing and religion, and they invented agriculture, and they formed the first empires that began to manipulate the world and the water around them, building the first dams and the first aqueducts. This is a slide of the Sa'd al-Kafara Dam in Egypt, built around 2700 BC, more than 4,500 years ago. And our ancestors invented intentional irrigation. They created the first water laws and institutions. And ironically enough, they fought the first wars over water. I'll talk about that in a little bit. But one of the things we do at the Pacific Institute is we look at conflicts over water. And the very first water war that we know of was at 2400 BC between two ancient cities of Sumeria in a fight over access to irrigation canals. Ultimately, the first age of water came to an end when rising populations and expanding cities and growing pressure on natural resources made us forge a new relationship with water. And the answer to those challenges was to be found in the science and the engineering and the cultural and philosophical blossomings of civilization that define what I call the second age of water. And as I hinted at the beginning, the second age of water is our age. It encompasses the hydrologic marvels built by the ancient Greeks and the Romans. We unlocked the biological, chemical, and physical properties of water. We understood what water actually was. We created the machines and the tools and the institutions to take advantage of our new scientific understanding. These are drawings from Leonardo da Vinci in around 1500, showing some of the tools and technologies that were developed at the time to deal with water resources, to bring water to us, to treat and manage water, to deliver and control water. And we built the first dams of gigantic scale, much larger than those early ancient dams, to hold back floodwaters, to store water in dry periods, to use in wet periods, to store water in wet periods, to use in dry periods, and to produce reliable hydroelectricity. This is Glen Canyon Dam on the Colorado River. And ultimately, we replumbed the entire planet. We learned about germs and diseases and their links to dirty water. And we then built the water treatment plants that provide safe water for cities with millions of people and that collect and treat our wastewater. We learned how to pump groundwater from deep underground so that farmers could grow food in places and at times never before possible. The Green Revolution that we often hear about, I would argue was actually a blue-green revolution. It was a revolution in irrigation technology and access to water as much as it was a revolution in access to better crop types or better agricultural technologies or pesticides and fertilizers. Without irrigation, we would not be able to feed the population of the planet today. And it's sophisticated irrigation and access to groundwater that permits us to do that. And in this second age of water, we also began casting our eyes and instruments outward to other planets, looking for water and evidence that we're not alone in the universe. And a lot of the science that we now have about the extent of water throughout the solar system and the galaxy and the universe comes from the technologies that we built in the second age of water. And modern civilization is built on these advances, and we've benefited from these advances in countless ways. We're mostly living longer, healthier lives. We're mostly richer economically, socially, and culturally, and mostly we take all of that for granted. But we're now also facing adverse unintended consequences of those advances. By the middle of the 20th century, we started to see and understand the first evidence of the loss of nature, the rise of environmental problems as the Industrial Revolution accelerated and as populations grew exponentially. We saw the first world wars. We saw and continue to see skyrocketing pressure on natural resources. Rivers and lakes were treated as dumps for our wastes, and they began to catch fire. And despite advances in water quality protections, serious problems remain. The environmental movement in the United States was in part spurred by a fire in 1968 on the Cuyahoga River. This is a photograph from the Cleveland University State Library of the Colorado River fire of 1952. It turns out the Cuyahoga River caught fire many times before that essentially very influential event in 1968 because of the wastes, the industrial wastes, the oils, the chemicals that we were pouring into all of the rivers around the country. And in fact, the Cuyahoga River was not the only river to catch fire. But again, despite advances in water quality protections that resulted from the environmental movement, the Clean Water Act, the Safe Drinking Water Act, those foundational national laws that to some degree protect our country from water pollution, we still have very serious problems. We have plastic pollution, we have algal blooms and toxic algal outbreaks. This is a photograph from a toxic algal outbreak in the Great Lakes just a few years ago. And we now understand that the causes of water-related, despite the fact that we understand the causes of water-related diseases and how to prevent them, they persist, including new illnesses associated with pollutants like mercury and lead and pesticides and complex agricultural and industrial chemicals. And of course, we still have some of those classic water-related diseases like cholera and dysentery and typhoid and malaria, because we have failed to solve water quality problems in much of the rest of the world. And perhaps worst of all, we've failed to provide safe water and sanitation for literally billions of people around the world, a problem that I call water poverty. That is the massive inequities in the distribution and benefits of the second age of water. You know, in the second age of water, we figured out how to solve the failure to provide safe water and sanitation to everyone. But there are billions of people worldwide today that do not have access to those benefits. And it's not just in other countries around the world. Many of you may know the stories of Flint, Michigan, Jackson, Mississippi, where mismanagement and underinvestment in water systems led to contamination and the loss of safe water for hundreds of thousands of people, mostly in poor frontline communities. And in my home state of California, hundreds of thousands of people, mostly in rural communities, in farm worker towns in California's Central Valley, in Native American reservations, don't have, or in some cases have never had, access to safe water or flush toilets or reliable supplies during extreme events. this issue of water poverty is a problem here at home as well. And violence associated with competition for access or control of water resources has also worsened. I mentioned earlier that one of the things we do at the Institute is we look at the issues associated with water conflicts around the world. One of the things we do is we maintain something called the water conflict chronology. If you're interested in conflicts over water, Google water conflict chronology and my name or the Pacific Institute, and you'll see the database that we maintain of water conflicts going back to that very first water war in 2400 BC. This is a graph that shows trends from that database from the year 2000 up until the year 2023, the last year for which we have full records. And it shows two different things. It shows, first of all, a very significant increase in recent years in the number of events associated with conflicts over water, with a dramatic increase really just in the last few years. And it shows it broken out by the three categories that we track. That is water as a trigger of conflict, where we fight over access or control of water resources in blue, water or water systems as casualties of conflict in red, where water systems are attacked and targeted during wars that aren't water wars. They're wars that start for political or ideological or religious or economic reasons, but where water systems are targeted during war, and water or water systems used as weapons during conflict in green. Again, as we've seen, there's a very significant uptick, especially in the Middle East and in most recent couple of years in the Ukraine, where dams have been attacked explicitly. Here's the destruction of the Kakhovka Dam in June 2023 by the Russians on the Dnieper River, the largest dam on the Dnieper River, one of the largest dams, if not the largest dam in Europe, destroyed during the war in the Ukraine. And civilian infrastructure, water infrastructure in the Ukraine has also been extensively attacked. This is flooding in the downstream river of Kherson following the release of water from the destruction of the dam in the Ukraine. We're running into peak water limits around the world as rivers are running dry, as aquifers are being depleted, as ecosystems are being destroyed. The ecological challenges of the second age of water are very significant. As much as 30% of global food production comes from unsustainable use of groundwater, which also depletes water available for natural ecosystems. We're strip mining the lands of forests. We're strip mining the oceans of fish. We're driving uncounted species of plants and animals to extinction. And the worst ecological problems we face, I would argue, are threats to aquatic ecosystems because of our abuse and mismanagement of water. And perhaps most worrisome of all, to the future of water resources and perhaps the future of humanity, is the challenge of global climate change. We know that climate change is real. We know that humans are causing it. And as the 20th century ended, scientists found irrefutable evidence that the combustion of fossil fuels and the destruction of forests are altering the climate of the planet, with impacts on every community and every natural resource, but especially natural resources associated with water, changing floods and drought risks, melting ice caps and glaciers and mountain snow, accelerating wildfires, increasing the demand for water needed to grow food as temperatures go up, damaging aquatic ecosystems. And all of us have seen in recent years the massive increase in extreme events, extreme flooding, extreme droughts, that scientists are increasingly fingerprinting to the issue of climate change. In short, the end of the second age of water is a race between the risks of ecological collapse, massive economic inequality, and political conflict, and the growing efforts to apply our hard-earned knowledge and technology to prevent these kinds of global disasters. It's time to both acknowledge the benefits of the second age of water and the need to make a transition to the third age, where we address the growing failures around us and make the technological and social transition to sustainability. And that transition won't be easy, but it's both necessary and, in my opinion, possible. Two paths lie before us. One to a dystopian future the other to a positive, sustainable future. And just as we can imagine a disastrous future, we can imagine a positive one. And just as our actions and choices can lead us to a bad future, they can also lead us to a better future with a balance between humans and nature, with growing equality and social cohesion, and with healthy, stable societies. And that's the future I focus on in my discussion and writing about the third age of water. And I believe this positive vision is possible and achievable. And in fact, I believe the transition is already underway. We're learning how to weave together a tapestry of actions and decisions and policies from individuals and communities and countries around the world to address the unresolved water challenges of the second age of water. And this is what I call the soft path for water. And let me describe a little bit about what I mean by the soft path for water. The hard path is what we've done in the second age of water. The soft path is what I argue we need to do for the third age of water. The hard path said, build for water supply. Populations are growing, economies are growing, demand for resources are growing, has been always the assumption. And that for water, let's build in a way that always finds new supply to satisfy that demand. The soft path for water says, rethink water supply, rethink what we mean, and think about options for water supply that don't require taking more water out of natural ecosystems, that don't require depleting groundwater, that don't require depleting our rivers. And I'll talk a little more about that, each of these, in a moment. The hard path said, satisfy this projection of future demand, this assumption that demand will always increase. And the soft path says, rethink what we mean by demand and think about how to do what we want more efficiently with less water, with less waste. And just as we need to rethink supply, we need to rethink demand, the demand side of the equation as well. And I'll talk about that a little bit more. The hard path says water's an economic good. The soft path says water's an economic good, but it's also a human right. And think about how to satisfy both the economic good aspects of water and the human right aspects of water. The hard path says let's build centralized water treatment to produce one quality of water, that is potable water. And the soft path says let's rethink protecting water resources and water quality, and also matching the quality of the supply to the quality of need. Not all of our water needs require potable water. Not all of our water treatment systems need to be centralized water systems, but increasingly can be decentralized. The hard path gave no thought to ecosystems or to ecosystem health. We didn't understand in the 20th century or the second age broadly the impacts we were having on ecosystems, or we didn't care. That's no longer valid. In the soft path, we have to protect ecosystem needs and ecosystem health. And we're beginning to understand the critical values of ecosystems for our own health. The soft path said, let's build centralized management institutions, limit public participation. And the soft path says we need community participation. We need flexible water institutions. All of these changes are things that I argue are not only necessary, but to some degree are already happening. We know how to provide safe water and sanitation to everyone on the planet. And the UN has set a target of that. One of the Sustainable Development Goals, SDG 6, says by 2030, provide safe water, sanitation, and hygiene to 100% of the people on the planet. We know how to do that. There's no technological marvels that need to be invented. We have enough money to do that. I don't think we'll meet the Sustainable Development Goal targets for 2030, but we could. That's achievable, and it's a critical challenge of the third age of water. We know how to use water more productively and efficiently to do the things that we want, include growing more food with less water. We can monitor our water use. We can change our outdoor landscaping. We have appliances that use much less water to do the things that we want to do. Think about it this way. we don't want to use water except for truly basic things like growing food and providing for basic survival. But we want certain kinds of benefits. We want to flush our wastes away. We want to clean our bodies and our dishes and our clothes. We can do all of those things that we want with less water. And that's the challenge of improving water use efficiency and doing what we want with less water. And again, we're moving forward on this path. We're moving toward cutting our water demands and yet increasing our efficiency of water use. And in one of the most clear examples of this, this is a graph that shows total US water withdrawals and the gross domestic product of the United States from 1900 to 2015, which is the last year for which we have complete data on water use in the United States. And it shows a couple of things. First of all, it shows that for the first 2/3 of the 20th century, water withdrawals, that is total water use in the United States, and the economic strength of the United States measured by GDP, to the extent that that's an adequate measure, grew together. And this was the fundamental assumption of economists and water managers and resource planners and so on, that growing GNP and growing populations, incidentally, would mean a demand for growing resources. But then in the mid-1970s, something happened. We split those two curves apart, and the gross domestic product of the United States continued to rise, but total water withdrawals in the United States leveled off and then started to decline. And the amount of water now required to produce a unit of GDP or to provide for a single person water use per capita in the United States is far less than it was 40 years ago, and far less on a per capita basis than it was 40 years ago. And this is a remarkable story that most people don't know. And this is evidence of a transition to the third age of water, where we're doing more and better with the water resources we're taking out of our ecosystems, and yet not hurting growing populations or growing economies. And I just got data for China, and China is showing the same kind of leveling off in trends despite rising population and despite rapidly growing economics. We know how to clean up and treat and reuse the most contaminated wastewater. Israel and Singapore today recycle and reuse nearly all of their treated wastewater. Windhoek, Namibia has been doing so for decades. In California, we reuse about 18% of our wastewater, and we hope to triple that in coming years. And when I said that part of the soft path is rethinking supply, this is part of what I mean. Treated wastewater, which we can treat to any standard that we want, is a source of supply that doesn't require taking more water out of groundwater or out of our rivers or out of overtapped ecosystems. And so is desalination. We know how to desalinate seawater. Seawater is about 97% of all of the water on the planet. We understand how to take salt out of water. We've been doing it for centuries in different forms, and modern desalination plants do it very efficiently. It's still very expensive. There are environmental liabilities associated with it, but this is also a potential source of supply in places where we're already efficient, where we're already reusing our wastewater, where there are no other options for providing alternative water supply. And again, we're seeing increasing commitments to desalination in the Middle East and the Persian Gulf. California has one desalination plant in San Diego. It's an option. We're learning how to restore and protect natural ecosystems that have suffered from our past abuse, including guaranteeing water for ecosystems for the first time, and removing damaging dams to restore free-flowing rivers. This is a photograph of the Elwha Dam in the Pacific Northwest on the Elwha River. This, until last year, was actually the largest dam removal project in the world. It was removed a few years ago in order to restore ecosystems and salmon runs on the Elwha River. This is what that river looks like today. And very quickly after the removal of the Elwha Dam, salmon and other endangered species were found spawning way upstream of the location of that dam site. And then last year, California started the newest large dam removal project on the planet with the removal of 4 dams on the Klamath River shared between Oregon and Oregon and California. And all 4 dams have now been removed. And again, salmon are starting to spawn in the Klamath River. An indication that not only can we protect natural ecosystems, but the ability of natural ecosystems to restore themselves when we remove the insults that humans have placed on them is potentially remarkable. We're slowly coming to grips with the need to resolve disputes over water peacefully and diplomatically rather than with violence. Although the examples in Gaza in the last year are distressing and a step backward, where water has been used as a weapon of war and where water systems were targeted during the war between the Palestinians and the Israelis. Ultimately, the coming years will determine how we choose to make this transition to a third age, whether we slip down into that grim and dismal future or whether we solve the crises that afflict us and make a shift to a sustainable, just, and peaceful world. As I said earlier, I'm convinced that a positive future is both possible and underway. I've worked with individuals and communities and companies and countries to begin to put in place solutions to our water problems that look at the things that are already working to try and figure out how to expand them and scale them up. There are no insurmountable technological or economic roadblocks to a positive third age of water. But whether we can overcome the political, social, and cultural obstacles that remain depend on the choices we make and how quickly we act. So in closing, let me read a few sentences from the last section of my book. I believe that a positive future in the third age of water is not only possible, but inevitable. Indeed, this optimism has permitted me to continue working on the critical challenges of climate and water and sustainability. And perhaps that's because the alternatives, the dystopian visions of our sci-fi novels and movies, apocalyptic movies and pessimistic doomsayers, are simply too depressing to accept. It would be a cosmic shame if alone in this small corner of the universe, our spark of intelligent life was not quite intelligent enough to overcome the challenges of living on a finite, delicate planet and fell back into a dark age of chaos, or worse, went the way of the dinosaurs. That's possible, but it needn't be that way. If we fail to achieve the positive vision for water, it won't be because we can't. It will be because we didn't. The hopeful vision for water I offer here is achievable and reachable, and pieces of it are already apparent in innovative, successful water efforts around the world. It's a future worth fighting for. Thank you very much.
Well, thank you, Peter, for that great overview, succinct and meaningful, and your words at the end, sharing the words at the end, because the issue of one's mindset working on these things really is important. And I kind of feel the same way. If you don't think about it optimistically, it's very hard to do the work every day, right? And
Yes.
so that's very much appreciated. I can relate to. Well, we've had some good questions come in, and I tend to go in order. And some of them I'll paraphrase. The first question that came in has to do with the militarization of transboundary waterways. And so, are there options to mitigate that militarization? Does the United Nations have any specific framework for that? And maybe I'll kind of overlay, you had those bars and so forth, and sometimes it's another country coming in and affecting a dam, like, with Russia and Ukraine. But how much of the conflicts that you see are on transboundary waterways? And is there anything, the UN is provided for guidance? Just it's a big
Yeah.
question. So I'll let you go whatever direction is appropriate.
Yeah, it's a big question. We do a lot of work on this issue. I could have just given a separate talk about water and conflict because of the work we're doing. And I could have showed another slide with that same graph with the number of events increasing over time, split out by what we call transboundary international disputes versus subnational disputes. And we see both in the database. We see more subnational disputes, that is violence between individuals or between cities and farms, between pastoralists and farmers in northern, in sub-Saharan Africa, more than the international violence over water. But there are transnational disputes as well. You know, the Ukraine-Russia conflict, those entries are international. The Israeli-Palestinian are categorized as international disputes. A vast number of rivers cross borders. Most of the rivers worldwide are actually international, and they include watersheds that involve 2 or more countries. Colorado River is shared between the US and Mexico. The Nile is shared by 10 or 11 countries now in Africa. Egypt is just the downstream country on the Nile. And there are treaties on many international rivers. Well, I would say maybe some international rivers that help reduce the risk of conflicts over water resources. When there's a dispute, those disputes go to a transboundary commission like we have between the US and Mexico on the Colorado, and we have on the Great Lakes between the US and Canada. But many international rivers don't have those kinds of agreements. So one of the challenges to reduce conflicts over water at the international level is international agreements about how to share water resources and what to do during disputes and how to deal with shortages and how to deal with data sharing. And the UN has a transboundary agreement framework. It's a voluntary agreement, but it does lay out principles for countries that share transboundary water resources. At the subnational level, it's a different kind of a challenge. You know, providing basic water services to 100% of the planet would reduce competition and violence over access to safe water resources. We've seen riots over water in Iran and India over access to water because they don't have water during droughts. Providing safe water and sanitation would be one technique, one approach for addressing some of the subnational challenges that we've seen.
Yeah, and just on the issue of the SDG 6 that you mentioned, and Jesse put a link for those who may not be familiar with it. I think you're a bit more optimistic about it being achievable in the near term, because it's for 2030 right now, but of course it should be achievable by some point. I'm going to go on to another question.
Aaron, just to be clear,
yeah.
I don't think we're going to reach the 2030 target.
Yeah, so
I argue that we could.
Yeah.
It's not, there are no technical or economic barriers. It's institutions, it's government failures, it's war. There are a lot of difficult factors associated with it. We could, I don't think we will. And I do think ultimately we will. That's my hope for the third age of water.
Well, that's good. That's good. Now, I'm going to read this next question, and I want to preface it by noting that the Water Resources Research Center is a nonpartisan. We don't get into political issues. Anything that Peter says is his own view, and I want to make that clear. But I'm going to go with the question as asked. In the U.S., the federal government plays many key roles in water issues. And these are the words: can you speculate on how various Trump administration policies may impact water issues? And I'll let you take that as generally, as you wish.
Well, so first, I'm a scientist, so obviously any comments I make about politics are my own personal opinion. It's hard to speculate. The chaos of the last 4+ weeks, since Trump was inaugurated, is amazing. I mean, the disruption of federal activities in every sphere in literally every sphere is sort of hard to understand. And it's hard to know exactly what will ultimately be the outcome of some of the proposed policies. A lot of the things are going to court. A lot of things are thrown on the wall to see what sticks. I don't know what's going to happen. But we do know that cutting resources for the Environmental Protection Agency will limit their ability to enforce some of the water quality, for example, water quality laws that they're required to protect. We had a Supreme Court decision today that further erodes the ability of the US EPA to regulate sewage discharges into waters. The Supreme Court ruled 5-4 to constrain the ability of EPA to implement certain kinds of rules to protect water resources under the Clean Water Act. Not the first of the Supreme Court decisions to affect water resources in recent years. And I expect some of these things will get a lot worse. But the environment is very important to people. A lot of the protections are written in law and can't be rolled back. So it's hard for me to know what the ultimate outcomes will be.
All right. Well, now we're going to go to a bit more of a local, but a scientific question as well. It asks for your opinion. What is your opinion on fossil water? For example, here in Arizona, water has been age dated with C14 to 6,000 to 9,000 years before present in the Wilcox Basin. That's an area in southeastern Arizona that's gotten a lot of attention, and an active management area was just formed there. And up to 33,000 years, a little bit further west in the same county. And we have, large basin and range alluvial aquifers across Arizona with, 10,000 years before the present that. So what are your thoughts about the rate at which fossil water is being used in different parts of the country and the world?
Yeah. So I wrote a paper a few years ago called Peak Water. It's in the Proceedings of the National Academy of Sciences that defines peak renewable water, peak non-renewable water, peak ecological water, and the constraints we face in each of those categories. And, I talked about overtapping rivers. The Colorado River is overtapped, doesn't reach its delta. That's a renewable resource. Using the Colorado doesn't affect how much water we get next year. Climate change will, but using it doesn't affect because it's a renewable resource. But fossil groundwater is a non-renewable resource. It's like oil. And part of the biggest challenges we face with groundwater around the world is the over-extraction of fossil groundwater, that is, taking groundwater out faster than nature recharges it. And when you do that, groundwater levels drop, it becomes more expensive and more difficult to pump over time. It's a non-renewable resource. It's like oil. And the biggest problem we face with groundwater now is the overdrafting of fossil groundwater. And as long as we overpump it faster than it's recharged, it has to be considered a limited resource. And we might want to use it up right now for current generations. But if we do, we have to understand that we're impoverishing future generations. We're making choices today that will be felt for generations to come. I'm not opposed to using fossil groundwater temporarily for emergencies, but it's an unsustainable resource when it's used in that way.
So the next question gets to questions about water governance and policy. And I actually, in case we had a shortage of questions, I wrote down a few questions of my own that I may come back to related to this. But the question is, water governance and policy help direct what we presently can do with water. And there's two questions. What do you see as the future of our existing water infrastructure institutions? And two, do we need a new type of water governance and institutional framework in the United States?
I think this is the hardest issue of all. I've said several times, I don't think we have technological barriers or economic barriers. Obviously there's some of those, but the biggest barriers we face to this transition to a third age of water, I think, is our institutions. Our institutions were designed in the second age of water more than a century ago for a world that I would argue no longer exists. And so we need to slowly, or maybe quickly, change our institutions to deal with the new realities. We manage water in small and centralized institutions dominated mostly by engineers, where water is not just an engineering problem, it's an economic problem, it's a social and cultural problem. We manage water over here and energy over here, when water and energy are very closely linked together. We use energy to produce and clean our water. We use water to produce and treat and deliver energy. And they're very closely linked, but our institutions are separate. And if our institutions were better integrated, we could deal with water not just as a water issue, but as a water, energy, food, and climate issue. It's going to require changes at the local level. It's going to require changes at the state and federal level. It's going to require changes at the institutional level, at the international level.
Yeah, and I'm going to ask a follow-up question here because, and I ask this not because in the context of what is happening with the current administration. This is something that in my training I looked at as an economist and looking at what level of government should be doing what. And having just been in Europe, in Malta, where they were talking about the European Union's regulations regarding reuse of treated wastewater, mainly for agriculture. They haven't really gone beyond that. And as I look at it, again, these are just my personal observations. There's more, let's say, centralization in Europe across independent country states than in the United States, where we have so much at the individual state level. So the follow-up question, do you see solution to more centralization of the government? You talked about systems. We talk about wastewater systems less. Do you have thoughts about that? And again, I'm asking this not particularly relating to the current, administration in Washington, D.C. I think it's a long-term question here in the States.
Yeah, so interestingly, water is managed and dealt with at many different levels, and that's actually very appropriate. Often water is a really, really local issue, but there are certain things for which federal, in the US, regulation is required. We have a Clean Drinking Water Act, a Safe Drinking Water Act, a Clean Water Act, federal legislation to protect water standards and safe drinking water, because we don't want 50 different state water quality standards. We want a single set of standards based on health. We have regulations for the efficiency of water using appliances. Now, interestingly enough, water use efficiency appliance standards first developed at the state level. California led the way in many ways, developing toilet efficiency standards and washing machine efficiency standards. And then Massachusetts adopted those standards, and then more and more states adopted them. And then the industry, the appliance industry, said, wait, we don't really want 50 different standards that we have to build 50 different kinds of machines for. We should have federal standards. And there are now federal standards for the efficiency of energy and water appliances. And that's sort of an example of the need for local reactions and institutions and standards and federal institutions and standards. Let's manage water at the level that's appropriate. And sometimes it's really the local level with local communities and local decision making. And sometimes it's at a much larger level.
Yeah. Well, thank you for that. I'm just going to note that our webinar goes to 15 minutes after the hour. We're now 7 minutes to 1 o'clock local time. And we know some people have to drop off because they've got meetings and so forth, but we will keep going as long as there are questions and Peter's willing to answer them. We had a question here that's a broad question about what are the trade-offs associated with pursuing the path of the soft path for water. And by the way, Peter, this is something you've been talking about for years and years, right? Yeah.
Yeah, I wrote a paper about the soft path for water in Science in 2003, I think it was.
Yeah.
And partly I developed the idea of the soft path because I saw soft path examples all around us and realized that we needed a new framework for thinking about water. I saw the curve splitting apart between water use in the United States and GNP and population, which is totally different than what water planners assume. And even today, water planners at the local level often say, well, look, here's our water demand today, and our population is going to grow like this, and we assume our economy is going to grow like this. Our water demand is going to have to keep growing too. We have to find more supply. And the evidence says that's not necessarily true. So I'm not sure what the trade-offs are. I see lots of advantages of the soft path. The economic costs are sometimes borne by different people than they used to be, or different communities than they used to be. That's maybe an institutional problem more than anything else. The institutions themselves will have to change, and that's a challenge because institutions are very slow to change. But in general, the soft path brings benefits in places that the hard path never did.
Yeah. Yeah, and then there's a comment just about the current cutting off of funds for water projects. And then, again, clearly what the federal government funds will affect what local governments do and so forth. So I think that I'll leave that more as an observation. Um, there's a question about thoughts on, and again, this is something that the audience may not be familiar with. So anything if you familiar and want to inform us, thoughts on why the sensible recommendations of the World Commission on Dams were pushed aside in favor of dozens, likely hundreds of new dams in many parts of the world, for example, the Mekong, Nepal, etc. That's not something I'm familiar with. I could project that maybe some others are not that familiar with. Do you have thoughts on it? And if so, maybe you could explain a little bit about it.
Yeah, so boy, that's an inside baseball kind of question in the water world. Many years ago now, the World Commission on something called the World Commission on Dams was created, and I think it was partly a World Bank initiative with environmental groups and governments to try and develop a set of standards for building big dams around the world. There were a lot of controversial big dams being built. Communities were being flooded and displaced. Ecosystems, of course, are disrupted and destroyed when big dams are built. It was run by Kader Asmal, who was the Minister of Water of South Africa at the time. He was the chairman of the World Commission on Dams. And they put forward a series of, as the questioner suggests, sensible recommendations for standards for when and how to build dams around the world. Part of the problem was that the recommendations were always, the Commission's work was always designed to be sort of voluntary, not imposing standards. There was no enforcement mechanism. There was opposition by the dam building world, and there was opposition by some big countries that wanted to continue, including and particularly China, to build big dams without constraints on how they built those big dams. Three Gorges Dam hadn't been built in China. China was displacing ultimately almost 2 million people upstream of where the dam was being built that was going to be flooded by the reservoir. They didn't want any constraints on how they built and operated that dam. And so basically national opposition, ultimately World Bank opposition, basically killed those recommendations. Having said that, some of those recommendations are still relevant and applied. Some of the international banks that fund big dam projects still use some of those recommendations in whether or not to support international projects, the projects that require international funding. So those recommendations did have some impact.
Okay, and then there's I'm looking at, there's still a number of questions and we've got just over 15 minutes, so I'll try to ask them quickly. There was a question about how far do you see the effects of weaponization of water in Africa, particularly relating to global health? So that's kind of again a pretty loaded question because it's assuming we know about the weaponization of water in Africa. And so maybe you could give a brief answer to that.
Yeah, so let me talk about weaponization of water more broadly, not just Africa. We're actually doing a project at the Institute right now looking at the links between water sanitation and hygiene, that is the WASH challenge, and conflict. And there are plenty of examples where in conflicts that start for whatever reason, if water is used as a weapon or water systems are targeted, attacked during conflicts, human health is directly affected. And maybe the best example is Yemen, where a long-standing civil war and then ultimately regional war led to very extensive attacks on the water systems in Yemen and led to what ultimately became the worst cholera outbreak in the world. More than 1 million, maybe 1.5 million, maybe 2 million cases of cholera in Yemen starting around 2018 because of the destruction of the safe water systems providing healthy water in Yemen. So when we see conflicts over water, when we see attacks on water systems, when we see water being used as a weapon, there are direct and indirect implications for human health.
Yeah. And somebody just put in a PDF about water wars and so forth. So people are sharing some resources here. Somebody asked a kind of question. This is more of a kind of at a more specific project level. What about the use of rock dams and other restorative practices for groundwater recharge purposes? Can this help for more long-term water storage?
So one of the big challenges, and maybe one of the big solutions, is figuring out how to capture more stormwater and use it to recharge groundwater. In California, we have a massive groundwater overdraft problem, as you do in Arizona, because if we brought too much land into production and we didn't regulate, monitor, and manage our groundwater. And there's now an effort underway to try and figure out how to capture more of the winter flood flows that we get and use it to restore some groundwater resources. And it's rock dams, it's flooding farmers' land that's not being planted during the winter to expand groundwater recharge. That's absolutely an important strategy. We have a report at the Pacific Institute about the potential for accelerating groundwater recharge by stormwater capture. It's one of these new solutions for the third age.
Yeah, and Patty, who asked that question, also made a comment around the time I think I might have talked about the EU regulations on use of recycled water, and noted that many cities are putting A+ wastewater directly into the potable water supply. And I don't know if Patty was on when I did my opening remarks or not, but on April 11th, we're hosting a water webinar, same time, same place, more or less, talking about what some of the cities in Arizona are doing in terms of planning for.
Yeah, so let me actually add to that. The Institute, you should go to our website, pacinst.org, PACINST.org. That's the Pacific Institute's website. Look on the publications page. We have a new publication that looks at the potential for stormwater capture in urban settings nationwide. And the too long don't read answer is that there's enormous quantitatively potential for capturing more urban stormwater runoff and using it either directly by treating and reusing that wastewater or using it for groundwater recharge.
Yeah. And when you were talking earlier about the matching the quality to the need, as part of the strategy that many have been using now for some time or implementing over time.
Right.
It made me think of the One Water approach that U.S. Water Alliance, City of Tucson, others have adopted. And the stormwater part of that is an important component, but one still to be developed. As you pointed out, that's an area with a lot of potential. Now, there's a comment here about the biggest barriers to the future of water and new realities is cultural. Again, it goes to your point about it sometimes being the governance, the people. Thinking about the future generations to come simply isn't profitable for some. This is, as Kendrick wrote. We need changes in the cultural mythology that defines what we think of as reality. So would you like to comment on Kendrick's comment?
Well, I agree with that. I do think there are cultural shifts happening. I do think that people really care about water. It's in some ways a classic nonpartisan issue. Clean, safe water is really important for everyone, polls have shown consistently. Whether we can translate that into effective legislative and political action, I don't know. And Dr. Megdal could comment on this more than me. There's also a shift happening in the economics world toward understanding the ecological values associated with natural resources in general. Environmental economics, ecological economics is not new anymore, but it's a growing field where we think about natural resources as more than just their dollar value, but their cultural and social and other values as well. And that will have an influence on the decisions we make.
And so here's another one that obviously somebody who's familiar with your work over time. And John notes, I'm impressed by the contrast between your balanced and equitable scientific presentation and your, in parentheses, equally admirable political and civil disobedience, in quotes, troublemaking. So this is John's view. Can you comment on this? So You can say no, yes, or decide what to do. I try to be egalitarian in fielding questions.
Well, look, I'm a scientist. I published quite a bit on the issue of scientific integrity and the role of politics in science. I feel very strongly that politics should not influence science in the sense that scientific findings should be independent of political opinion. Having said that, I'm also a citizen. I'm also a human being, and I have political feelings. And I believe that it's important for anyone who cares and wishes to and is able to speak out about things that they care about. I care about the integrity of science. I care about the value of science for society. My political comments tend to focus on the role of science in politics and the nation and the importance of good independent science for the nation. But that's a personal decision. We all have to make those decisions at a personal level.
So here's Greg, who notes, having a degree in physical geography, but back in the 1980s, we were led to believe that by growing populations, there would be a reduction in agricultural water use and demand. Is this still the common belief? And I'm going to overlay on this a question to consider as well. We know that we've got urbanization that's causing farmland to be retired in areas. The question, maybe you have some thoughts about how are we going to feed the population in the future as some agricultural lands are permanently retired and made into houses. So I'll let you take it from there.
Yeah, these are all great questions, and this is another big issue. There are two ways to think about this. One is how much water is being used to grow how much food. The other is there a way to grow more food with the amount of water we're already using, or grow more food with less water? And that gets back to this question about water use efficiency. You know, in California 30 or 40 years ago, almost all of the irrigation was flood irrigation. We flooded our fields, and a lot of water was lost to contamination. A lot of water was lost to unrecoverable groundwater. A lot of water was lost to unproductive evaporative losses. Today, the vast majority of our agricultural land is irrigated with drip irrigation or precision sprinklers, and we're using no more water for irrigation today than we did 10 or 20 years ago, but we're producing a lot more food and a lot more revenue for farmers. So can we continue to produce the food that's required for the globe, given all of these challenges, by improving efficiency? That's one of the big challenges. It's tied to this groundwater question that we've talked about a couple times. A lot of the world's food production comes from unsustainable groundwater overdraft, and replacing that is going to be a big challenge. In California, bringing groundwater back into balance is probably going to require taking 500,000 or 750,000 acres of land out of production. Now, we have 8 million acres in production in California, so that's not going to cripple California agriculture, but it's going to lead to changes in how much food we produce, how much food we're able to export, the kinds of crops we choose to grow. All of those things are relevant. But I would add one more factor here. Also relevant to this is people's diet, the things we choose to eat. The things we choose to eat has enormous impact on the things that farmers choose to grow, and ultimately on the amount of water required to do those things. It takes a lot more water to grow a ton of beef than it takes to grow a ton of wheat. And thinking about diet, which is sort of the same idea, think about demand on the water side, think about demand on the food side, is another important part of our challenge.
Yeah, and at the same time, we want conditions to improve for those who may not have enough protein in their diets and so forth. So there's many factors at play affecting that demand for water. Here's a question about conservation. So what are some concepts, and I'm looking, we have about 5 more minutes. What are some concepts for incentivizing water conservation in our state? And this is somebody talking about Arizona, but it might pertain almost anywhere. For basin water management agreements, this person saying we're creating a rush to the pump house to get bigger demand on our accounts in the new AMA. So this is very specific to kind of some of what's going on here, which you may not be familiar, but I think the general question about concepts for incentivizing conservation would be useful to hear your thoughts about that.
Yeah, I won't comment about Arizona's specific cases, but what Arizona's experiencing is not you're not alone. Let me put it that way. And there are lots of different strategies for this. I'm a fan of let many flowers bloom here. Sometimes I think regulations are critical. You have to regulate certain kinds of things. Sometimes I think economic strategies are really critical. You want to price water properly. You want to let ecosystem values be included in economic decisions about water resources. You know, if the economic value of water is zero, you're not going to protect the water required for ecosystems. So again, rethinking ecological economics and how we deal with economics is an important piece of this. Sometimes it's community decision making. There are lots of different tools for incentivizing changes that could lead to the positive third age of water, and I'm in favor of whatever works.
Okay, so I'm going to abbreviate a couple of like maybe two questions, and they're both significant ones. So I know I'm not going to do justice to them. But Mark Anderson talked about some of the situation up at the St. Mary and Milk Rivers in US, Canada. And his real question is, should water be shared based on kind of equitable quantities, or should we look at the economic value of what's resulting from the water? And Mark, I hope I'm doing your question justice. And it may be okay if Mark gets in touch with you afterwards if you've done not adequately justice. The other one I want to just voice, and like I said, we're down to our last few minutes, and this is a big question. Any thoughts on the rights of nature? So those are, I'll let you determine how you want to use the last 3-4 minutes here.
Okay, so each of those deserves their own seminar. I'm sure you could find experts to address them. On the first point, this has been a debate for a long time. I mentioned very briefly the UN Watershed Agreement. One of the principles for international sharing of water resources is called equitable utilization. And there's been a long debate about equitable utilization. What does that really mean? Does it mean the same amount of water to different countries? Does it mean the same amount of water per person available to different countries? Does it mean that the first country that was using the water has a right to use the water over a use that develops later in time? These are all debated, and I don't have good answers for them. They're often very watershed specific. They're politics specific. Professor Steve McCaffrey, who's at Pacific Law School in the Central Valley in California, has done a lot of work. He was one of the lead negotiators for that UN agreement. Has done a lot of writing on what equitable utilization means. I would encourage you to do that, to look more deeply than I can possibly answer in a short period of time. In terms of the rights to nature, you know, the UN declared a human right to water in 2010. After a long debate, there's now a formal legal human right to water in international law for human uses of water, for water and sanitation. There are hints that there's a right to water for nature. It's less well codified, it's less well understood. We're starting to address it in some places by providing minimum flows in certain ecosystems for certain rivers for water, by taking down dams to restore flows, by providing water for protected ecosystems and protected species like salmon. When we have endangered salmon, we have laws to protect them. And so we're trying to provide not necessarily legal human rights, but legal rights, but in effect, rights to water for those endangered species. We're beginning to see it. The new Constitution of South Africa, new in 1994, after the fall of apartheid, wrote into their constitution that humans and nature had a right to water. So we're beginning to see at the state level, the national level, some declarations of rights of nature. But I think it's an area ripe for a lot more work.
Well, in addition to some comments about great talk and the legacy of your work, I want to thank you and for sharing your insights and expertise with us, answering all these questions. And I do want to give you a moment. The book came out in 2023, And I'm assuming people can find it on usual places to find books. Is it both in ebook and hard copy, paper copy?
It's in paper, it's in hard copy, it's in ebook, it's in audiobook. I recommend you go to your favorite local bookstore if possible, or bookshop. I think it's bookshop.org, which is an independent online seller. But wherever it's available, wherever you find books.
Okay, well, I want to encourage people to take a look at that. And thank you, Peter. Thank you, everybody. The recording will be posted within the next 24 hours or so on our website, and those who registered will get notifications. So thank you so much. It's really been a delight to host you.
Thanks for having me, and the questions were great. Appreciate it.
Thank you.